Alright, hi you guys and welcome. Today we'll be talking about arithmetic sequence and series. Okay, so an arithmetic sequence is just a list of numbers. An arithmetic series where you take that list of numbers and you add them together. Okay, so the cool thing is that an arithmetic sequence, here is the formula to find the nth term in that sequence, and an arithmetic series, here is the formula to find the sum of that series. Okay. Alright, and I forgot to add these terms earlier. So this is S sub n equals n times a sub 1 plus a sub n divided by 2. Okay, now the recursive formula to actually find the arithmetic sequence that you're working with is pretty easy to set up. So it'd be a sub n equals a sub n minus 1, which is the term before it, and then you add the common difference. Okay, so that one's pretty simple right there. Now, this is seriously just a review of what you've done in Algebra 2. So the common difference is where you take the second term and minus the first term, or you could take the third minus the second. Whatever it is, you take one term and minus the one from before, and just work with it that way, okay? Right. Now, the recursive formula is to actually come up with the actual formula. To come up with the explicit formula, okay, so that would be a sub n equals, let's do common difference times a sub 1 plus the 0th term. Okay. Alright, now the 0th term is actually the first term that comes right before it. Okay, so just as long as you work with that, you should be totally fine with just being able to do it, okay? Well, no, actually, shoot. Can't believe I forgot this. This is actually just n. Move this out of the way. There we go. Okay, and that's to find any term in this actual sequence as you just work with it, okay? Alright. So that's the explicit formula, and that is the recursive formula. As you can see, they're a little bit different, but they actually work out pretty darn well. Now, for a lot of you guys that may have forgot this stuff since Algebra 2, n is the number of terms, d is the common difference, a sub n is the nth term, a sub n minus 1 is the term before the nth term, okay, and a sub 1 is the first term of that actual sequence, okay, as you go. Alright, now an arithmetic mean is actually just the differences between the actual two. Well, when you list out the numbers and you have some blanks, you can actually use the arithmetic mean to help out. Alright, so let's say we're given an actual sequence or starting of a sequence like this. Okay, now the arithmetic mean is seriously just going to be our usual mean. So what we're going to do is we're going to take 3 plus 15 and divide by 2. So literally, to get that term in the middle, 3 plus 15, and then we're going to divide that by 2. Okay, and that's going to be 18 divided by 2, so this middle term is 9. Okay, now to fill in the other terms, we just do the arithmetic mean with that. So 3 plus 9 is 12, divided by 2 is 6. Okay, 9 plus 15 is 24, divided by 2 is 12. Okay, and as you can see, I can actually see the common difference popping up. The common difference is actually going to be plus 3 each time. Okay, and that's how you find the arithmetic mean, and that's where you use the arithmetic mean to your advantage in this. Okay. Alright, so now here's where we need some rusty, probably some, to shake the rust off our boots in order to go forward, okay? So I give you 4 situations where you might have to find the difference you might have to find a different variable for each situation. So just understand that even though it's a very simplistic formula, this sequence formula, it's actually very helpful because it helps solve a lot of situations, okay? Alright, so first off, find the common difference. The common difference is going to be 11 minus 8, or you could do 14 minus 11. Either way, you're going to get 3, so the common difference is 3. So a sub 25 is going to be the first term, which is 8, plus 25 minus 1 times 3. And you could seriously do all of that on your calculator. Okay, so we put in sub 25 right there. Alright, so 8 plus 24 times 3 is 80. Okay, so the 25th term in this sequence will actually be 80. And voila! You found the 25th term with just giving a list in the numbers of the sequence. Okay. Now find the n for this sequence. If you notice, I started at 19, 14, 9, and go all the way down to negative 41. So we don't know n in this situation. Okay, but we do know the common difference is going to be negative 5. So that's pretty simple. So what I do is I replace everything, and this is actually going to be my a sub n. Okay. So negative 41 is equal to 19 plus parentheses n minus 1 times negative 5. Okay. All right. So first off, I'm going minus 40. I'm going to minus 19 from both sides and get negative 60. Okay, equals n minus 1 times negative 5. I'm going to divide both sides by negative 5 and get 12. 12 equals n minus 1. Okay, and I'm going to add 1 to both sides, and 13 is actually going to be n. So as you can see, it's really easy to do it. Now I know some of you guys are wanting to distribute the negative 5 because that's what you've been so used to over all these years. But remember, we're solving n. When you have something that's already been factored out, it makes your job a whole lot easier. Just keep it factored. Plus, this is a very good technique to keep this like this. That helps you for calculus. So please understand, keeping things in factored form actually helps out later on. Okay. All right. So what is the first term of the sequence if a sub 7 is 10 and 2/3 and d is 1/3? Okay. So this one's actually quite interesting. So we know the last term, so it's going to be 10 and 2/3. I just write a space between them to represent that. And then a sub 1, I don't know. I do know n, so this is going to be plus 7 minus 1, and the common difference is 1/3. Okay, now some of you guys might be going, oh, that's not as easily found, but as a matter of fact, it's really easy because 7 minus 1 is going to be 6, and 6 times 1/3 is going to be 2. So this makes my job a whole lot easier. So I got 10 and 2/3 equals a sub 1 plus 2. Okay, and I just kind of click on the cursor right below it. So what I do is I actually minus 2 from both sides, and then what do I get? I get 8 and 2/3 equals a sub 1. And that's my first term just by knowing that sequence. Now, could I test that out and actually work with it? Yeah, you should probably test this one out just to make sure you're able to actually work your way through it. But, you know, if you trust the math, you should be good. Okay, so in this one we found the nth term. This one we found n. This one we found the first term. Now let's find the common difference if we know everything in between. Okay, so I can actually just use my formula. So 58 equals 6 plus n minus, well, n minus 1 actually isn't there. It's 14 minus 1 times d. Okay, so I'm going to minus the 6 from both sides, and so I get 52 equals 13d. Okay, and we all understand that that is looking like a pack of cards because 52 cards make up a pack of cards, and 13 goes into 52 4 times. It should be an awfully common number. So there you go. Finding one of each variable in each situation should be pretty easily. Now, just word to the wise, sometimes when you're finding on a series and you're given the first term and the, if you notice, you don't need the common difference here. But sometimes you might not be given the 15th term. You might need to use this formula first. So you might need to use this first and then plug it in here, whatever answer you get for the nth term, and then you can actually find the sum. Okay. Now, just a quick talk about arithmetic series and sequence. We can go with a sequence forever, but a series of arithmetic cannot go forever because you can't find the sum. You actually have the finite, but we'll talk more about that in a sec, okay? All right, that's it for working with in pre-calculus B, arithmetic sequence and series. I'll talk to you later. Bye.